This is our very first chapter. Very, very light information here again. There is going to be a lot of things that you will hear tonight, which are, you know, they don't really happen like that in real life, but those are more conceptual information that I'm giving, like, just to give you an idea, and then we'll go move on step by step and we'll see how it happens in real life. But in order to see what happens in real life, we need to see what is the story behind it, right? So we're gonna talk about all those behind stories tonight.
Okay.
So let's talk about the agenda again. For tonight, what we are going to do, we're going to look into what is software testing, right? First thing first, the very first important question, what is software testing? We're going to answer that for you. And then why it is important, right? What are the benefits of that? Then we'll look into, the two main, I would say, types of testing. One is the functional and the other one is the non-functional. We'll look into that. Then after that, we'll have some testing principles. I believe these are the principles that every tester should keep in mind. So we'll talk about them. And then we'll have some software development life cycle, the introduction to that, and STLC, software testing life cycle, introduction to that. Again, it's going to be an introduction, but there's going to be a lot more in detail that we'll see later on as the course progress. And then at the end, we're going to see the acceptance criteria. There's a lot to cover for tonight. So if there is no question, let's just then if there is no question, then we can proceed.
Yeah,
Or
no questions right now. I will dive into it as we go by. I feel like I think I'll have more questions as we go through the each of the categories.
yeah, yeah, again, yeah. So this is again just an agenda. So you're not limited to any particular time of question and answers. You can ask anyways, anytime. Okay.
Okay.
All right. So the very first question that we can think of is what is software testing, right? Um, if we go by the definition, then it's a method to check whether the actual software product matches expected requirements and to ensure that the software product is defect free. In another words, I would say anything that is expected, the actual
Mhm.
product has to be exactly like that, just like the expectations. So
Okay.
any variations or any deviations from those expected requirements is a defect.
Okay.
Okay, so
So the
testing
go ahead, go ahead.
software testing is basically a way to check whether the actual product, matches the expected requirements and to ensure that, any variation or deviation is not there. Okay.
Okay.
Of the software testing is to identify errors, gaps, or missing requirements in contrast to actual requirements. Okay, so again, you are responsible to also locate the gaps that they might have never thought about when they were writing down what the software should be look like or what the software should do functionality wise, right? So
Okay.
any gap that is out there, you're responsible for that as well. In simple terms, software testing means the verification of application under test. Okay. So
Okay.
so again, it's all about quality, right? As a tester, you're responsible for the quality of the product itself. So anything that you think would lower the quality, your job is to capture that and then report that. Okay?
Okay. Yeah, so in terms of it says that the actual software product matches expected requirements. So the expected requirements, where do they come from? Do they come from maybe some of the people who started the project? Do they come from external parties? Where do those expected requirements come from?
Good question. So now two things can think of yourself as someone working, for example, in a bank, and for example, there's a customer service department, and they want to have an application where they can, let's say, log all the defects, all the issues related to their customer services and whatnot, right? And then they can
Yeah.
track those issues and resolve for the customers. Let's say they want
Mhm.
an application done like that, department want it done like that, the budget is approved, then the requirements, the actual requirements are going to be come from, the business side, which is the customer service representative team, right? They will tell
Okay.
us what they need. These are the root requirements. But again, then there is a lot of people involved, that would, at the end of the day, would bring the requirements to you. But for now, you can think that the requirements, they come to us from the business side. Or, for example, if you work in a software company that creates software for someone, right? Then the requirements will be coming from your client side. For now,
Okay.
we can keep it simple as that. Later on, we'll see, what we can do about it. There's a lot of things in there. We'll talk about them later on. Okay. But
Cool.
in
Yeah.
simple, the requirements, what the software should do, what the features of the software are, what the functionality should be of the software, they all are told to engineering team by the business side or by the clients. Okay.
Yeah.
Why software testing is important? Because if there are any bugs or errors in the software, it can be identified early and can be solved before delivery of the software product. Properly tested software product ensures reliability, security, and high performance, which further results in time saving, cost effectiveness, and customer satisfaction. So again, your bug in the system will not cost you much if your system is still under development. But once
Hmm.
you are in the market, and there is your product is of a buggy product, there's a defects in there, right? In that case, you can, have you can have problem with your reputations, customer satisfaction, and overall business loss kind of situation is there. So that's why it is important to figure out those defects way in advance, way before we reach out to the actual end user.
Okay.
Okay, so again, similarly, what is the need of software testing? Now, there are a few points that I have mentioned here. And there's millions of examples out there. So if we look at some of them, like this one is very interesting. Nissan cars recalled over 1 million cars from market due to software failure in airbag sensory detectors. So you see how much it cost them. Imagine if they had found it while it was in under development, right?
Yeah.
They wouldn't have to have all that hassle. Similarly, Starbucks was forced to close about 60% of stores in the US and Canada due to software failure in its point of sale system. At one point, the store served coffee for free as they were unable to process the transactions. So you see,
Wow.
there's not just the loss of money, but there's a loss of reputation as well, as you progress. So now there's another one in 2015, fighter plane F-35 fell victim, to a software bug. Now these planes, they cost like, millions and millions of dollars. They're expensive planes, right?
Yeah.
And again, there's a big loss right there. Similarly, China airline Airbus A300 crashed due to software bug on in April 1994. 264 innocent people died. So again,
Wow.
everything that we have right now, everything around us, and everything is going to be, also like, it's not going anywhere. Everything is going to be all softwares around us, right? And all those softwares, they need to be tested.
Hmm.
So
Okay. So in this situation, either they didn't anticipate the bugs beforehand or it wasn't tested properly, the software. Is that true?
yeah, again, either way, something got missed, which
Yeah.
was supposed to be like, in an ideal situation, you're supposed to know all these things beforehand, right?
Okay.
So again, if there is no testing, there's no presence of defects. You won't be able to find any defects if you won't test it. Um,
Okay.
okay. Oh, sweet. Now, what are the benefits? Again, cost effectiveness, security, product quality, customer satisfaction. These are like, some of the benefits that are listed, but then again, there's endless benefits. Again, it's at the end of the day, it's your product. You want to make sure it's working. It's
Hmm.
as high quality as possible.
Yeah.
Okay, now let's talk about the functional and non-functional testing. So the functional testing, there is, again, as I said earlier, that there is tons and tons of types of testing out there. We're going to explore all of these, the most important ones later on, like for example, unit integration and smoke. We'll talk a lot more about them later on. But if we see that there is two big categories of testing. One is the functional testing, and the other one is the non-functional testing. The functional testing talks about, the functionality of the application. In the functional testing, as the name suggests, you make sure that the functionality of the application is working as expected, right? The behavior of the application is working as expected. So, for example, if I'm changing the address of the customer and I hit save, it should save, right? This kind
Yeah.
of functionality testing is, called functional testing. And then there's a lots of subtypes that are there, Similarly, we have non-functional testing. Non-functional testing are more about the look and feel of the application. For example, how the application looks on a bigger screen, how the application looks on a small screen, for example, and a mobile phone, right?
Yeah.
Similarly, how quick the application is, how quick it is able to provide the response, how much load it can handle, right? How many, like for example, if it is scalable or not, usability wise, is it easy to use or not? So non-functional testing is all part, like, of it talks about all the look and feel of the application, whereas the functional testing focuses on the functionality of the testing. We are going to be focused on functional testing of the application because this is where mostly the jobs are. Functional testing is, that has a lot of jobs out there in the market. Okay, and again, the sky is the limit when it comes to functional testing. You could be an automated tester, you could be, manual tester, you could be testing functionality at the API levels before even the graphical user interface was made. You can also test the functionality in the backend on the database server itself, right? So there is endless ways of getting things tested. We'll talk about all of them later on in the details.
Okay.
Now, here is one more thing, the software testing hierarchy. Again, this is not how it's going to look like when we proceed later on in the course. But generally speaking, there's a lot of other steps that take place in between. But when we talk about the testing steps, so first is the unit testing. Unit testing, you can think of,
Okay.
something like, a simple one unit was developed by the tester, and then the same unit got tested by the developer, not the tester but the developer. We'll see again
Okay.
on about the unit testing class tonight. We'll have more detail coming up for this later on, but the unit
Hmm.
testing itself is basically gets done by the developer. You can think of this as a simple one brick. You build a house brick by brick. So you put
Yeah.
one brick. The mason who put the brick, he's just checking, if the brick is sitting properly with the other brick, on the other brick. It's if it is like, connecting properly with the previous brick or not. So, again, not the previous brick and all of that, but like, you set up the brick and you're looking at it, as a mason that, if the brick is done properly. So that's unit testing itself. We'll talk about more in that later on. Now, the integration testing is, on the other hand, once one unit is developed, it needs to be integrated with the rest of the application, right? So integration testing talks about, integration of that unit, so it tests on the integration part of it. Again, the
Okay.
details, we'll talk about them later on. Now, let's talk about the system testing. System testing is, as the name suggests, is overall one whole system, right? Now, in the application, what happens that there's a lot of small systems and they come together and they make one big system. So in the system testing, you're going to test everything from, let's say, point A all the way to point Z. So
Yeah.
everything, one whole system get tested. And then at the end, we perform the acceptance testing. The acceptance testing, the sole purpose of acceptance testing is to make sure that if our application would be accepted by the client or not.
Okay. So it basically first the tester tests piece by piece and then the whole overall application. So there would be multiple different aspects of this. So piece by piece and then the overall thing at the end. Is that correct?
Yeah, so think of this way. So very first time when somebody is like, working on something, they're just gonna be working on one unit of an application, one piece
Yeah.
of application, for example, right?
Yeah.
Uh, so when they are done making that one piece, they want to test it right there, that one piece. If that
Yeah.
piece, for example, let's just say that, a text field is supposed to hold 16 items only, 16 characters length,
Yeah.
right? You cannot put, let's say, my name is only 4 letters long for us, for example, right?
Yeah.
You cannot have more than 16 letters, for example, right? So
Hmm.
that unit itself, the testing of it of that unit itself would be like, me trying to do 16 characters, under 16 characters, more than 16 characters and whatnot. But again, testers don't do unit testing. The one who built that unit would be
Yeah.
testing that unit as well. The developer's job to do the unit testing. And
Okay.
then they integrate that unit with the rest of the application, right? And that's when the integration testing happens. We test, how this piece that just got developed is integrated with rest of the application, how it is behaving with the rest of the application. Okay.
Yeah.
After that is like, the whole system, like from point A to point Z. And then the last, the top item in the hierarchy is the acceptance testing, where you want to make sure that your application gets accepted by the user. Okay, so you
Okay.
put yourself in user's shoe and you test the application, and your question that you'll be asking is if the user is going to accept it or not. Again, there's a lot more going to come into all of these things, but it's just the introductory right now.
Okay.
Okay. Now there is principles of software testing. Now, nobody's gonna ask you this question in the interview that what are the principles of software testing? Nobody's going to. This is just for your own, uh, purposes. Like, a good tester should have these things in their mind. One is that testing shows the presence of the defect. So if there is no testing, there's gonna be no defects, right? So you gotta test in
Yeah.
order to find defects. Exhaustive testing is not possible. There's going to be more coming on this. But let's say if you have an input to test from 1 to 1,000, are you able
Hmm.
to do like each and everything? You enter one and see the response, you enter two, and then you see the response, and you gotta go all the way to 1,000. You can't really test all that, right? All the way from
Yeah.
1 to 1,000. It would take you a lot of time and it would exhaust you out.
Hmm.
Similarly, the third one is early testing. So it's always good to test early, as early as possible. Okay. Then
Yeah.
is the defect clustering is you can think of that as an as you know what happens most of the times that a lot of the defects are found in, let's say, one or two modules. So, for example, you have 80% of the defects, and let's say 20% of the application. Rest of the 80% of the application is good. So, 80% of the defects are clustered into 20% of the application. The reason could be that, those particular modules are very complex modules to develop, right? So as the complexity increases, the chances are that the number of defects are going to increase as well. So this happens a lot of times that a lot of defects are clustered into one space. So the
Mhm.
point is that if you find one defect in one module, the chances are that there's going to be more. Do not get done with, once you're done with one defect. Don't think that you're done with one feature. Chances are there's going to be more. Okay, similarly, number five is pesticide paradox. So as the name suggests, pesticide paradox. So I don't know if you remember, if you've seen it, that if you keep on spraying one particular type of pesticide, the bugs they they develop the immunity to that. They
Mhm.
are no longer they're no longer being hurt by that pesticide, right? Because they're used to of that.
Okay.
Similarly, you cannot use same techniques on every project or every feature of the application. You have to adopt new ways of finding defects. Okay, and you have
Okay.
to take every new feature as a new feature and then work on it from a fresh mind. Okay.
Yeah.
Now the next thing is testing is context dependent. What it means that if you have some context, only then you can test. Remember, the context is the requirements. For example, if you have the requirements, only then you can test. You
Mhm.
cannot assume anything. Okay,
Okay.
so that's the
Yeah.
principle again you want to adopt as a tester. Before you become a tester, you gotta adopt these in within yourself. Now the last one is absence of errors. Absence of errors, if you look at it, is totally opposite to testing shows presence of defects, right? Now,
Yeah.
if you're testing and there is no errors coming up, like for example, errors of absence of errors is a fallacy, right? That
Yeah.
is that could be the reason that if there is no errors, if there is no errors coming up, if there is no defects coming up, maybe you're testing everything wrong. Maybe your
Mm.
whole direction from the day one, was wrong. Maybe your requirements are wrong. You're testing for the wrong requirements, you know. So again, if there is testing, there is defects. If there is no testing, there's no defects. So the chances are also that if everything is going 100% smooth, you know, there is something missing for sure. So we gotta figure that out. It cannot be that everything is smooth. That doesn't happen very often. Okay.
Yeah. So in that case, do you backtrack and you go to get the requirements again, or what happens in that case if
I
it
would
does
just
end up going
I would
perfect?
just double check everything, that everything is there, everything is good, if the requirements are good, if the testing that I'm doing against those requirements, those are good. So but again, testing should show the defects. If there is no
Okay.
defect in one module, that is not happening. Okay, it makes sense. But it's not possible that every module that you're getting is without any defects. Okay.
Okay.
There's no defects, there is something wrong for sure.
Okay. No worries.
Okay.
Yeah.
Let's move forward. Okay, so this is actually about the fundamentals. Now the SDLC and STLC. Now first look at the SDLC as SDLC is just an acronym,
Mhm.
and SDLC stands for Software Development Lifecycle. So again, if we look at it, every software was once an idea, right? And then that idea
Yeah.
became software product, right? So similarly, that idea, you know, goes from the state of idea all the way to a product, gets delivered. So this is again, this is the life cycle of the software, right? From idea to delivery. Now, if we
Okay.
look at it, there is multiple stages in that. So one is the analysis stage. The other one is the design stage. The third one is the development stage, testing, then deployment, and then maintenance. So what really happens, first thing first, you gather the requirements. Requirement gathering is the very
Okay.
first. So very first time, let's say someone comes to you and say that, hey, I want you to create an application for me, a mobile application or web application, whatever, you know. And the next question that you're gonna ask, okay, what is it? What kind of things are going to be in there? What are your requirements? Right? So you very first thing that you do is you gather the requirements. The
Yeah.
next that we do is the design stage, right? In the design stage, there is people like system architect, the user experience, user interface designers, the designers of the application, who not limited to the system itself. For example, what kind of database it will have, what kind of let's say the language we are going to use to develop this application and whatnot, right? Not only the
Yeah.
system, and tools of the design, but also the look and feel of the application, right? So that also happens in the design stage. The next one is the build stage or the development stage. This is where the backend developers, they write the backend code. The front end developers, they write the front end code, the body of the application. The backend developers, they write the engine of the application, for example. Let's put it this way, right? And then the next
Mhm.
thing is the testing phase, right? The testing
Okay.
phase, this is where the engineers, the QA engineers, they come into play, the testers and all those guys. So what happens once you have something developed, you start testing on it, right? So this is, as the name suggests, this is a testing stage. You are testing in this stage.
Yeah.
And once everything is developed and once everything is tested and all good, then you deploy that. You deploy that to the server, you know, where people can access it. For example, www.google.com, google.ca, this is an access to, this is this is an address to the server, Google server, right? And you
Yeah.
deploy your software similarly to your own server. And
Mm.
once the deployment is done, after that is the maintenance stage. So, for example, if you want to, add more features into it, or if there is defects that are, or some changes that are recommended by the users, actual users of the application, right? And then you go on in the maintenance stage. So again, there is 6 stages: requirement gathering, design, development, testing, deployment, and the maintenance.
Okay. So over here, the testers are actually involved in from testing all the way to maintenance, basically, right?
Yeah, testers are basically not, again, uh, if we look at it, this is also called a waterfall design, waterfall method. We'll
Yeah.
have a lot more coming up in terms of waterfall and how the project management works. So waterfall used to be project management methodology back in the days, where if you think about it, this is like a waterfall. So one stage, after one stage, you go into next stage, and then you go into next stage, and then you go into next stage.
Yeah.
Now, the problem with this one is, for example, you started doing testing, and it took 3 or 4 months to get all these things done. And when it comes to testing, you found the defects that are very critical defects, for example, and then you might have to go back and change the development, or you might have to go back all the way to the design, change the design of the application, or you might have to, sometimes go back to the requirements and see, what we're doing is like, wrong. But like, if you think about it, 4 months gone wasted. So
Yeah.
nowadays it doesn't happen like that. Again, when we talk about agile in later on, in project management
Mhm.
classes, then we'll see how it happens. But in reality, again, like, these are the 6 stages that a software goes through. whether we do them in a short period or we do it in the waterfall methodology, there is these phases that a software goes through in order to get delivered. Okay,
Okay.
we'll have
Yeah.
again a lot more in this. Again, tonight's class is only just the introduction.
Okay.
Okay, we're just touching the tip of the iceberg. We're not like, diving into anything right now. We're just looking at the tip of the iceberg for now.
All right.
Okay, so the next, similarly, we have software testing lifecycle. So first we looked at software development lifecycle, which was SDLC. Now is software testing lifecycle, STLC. So similarly, software testing lifecycle is a sequence of specific activities conducted during testing process to ensure software quality goals are met. Now, if we look at it, there is again their own stages. So we had previously we had requirement gathering. Over here we have requirement analysis stage where we're analyzing our requirements, right? And then we plan the testing. For example, who will be doing what kind of testing? At what point which testing needs to be included within our testing. And
Yeah.
for example, the estimations, and all those things take place right here during the test planning phase. And of course, once the planning is done, then you want to write your test cases. So doesn't matter if you have an application, built already for you, a feature built already for you or not, but you have the requirements, and based on those requirements, you can write your test cases, right?
Okay.
What this application should have, what this application shouldn't do, all those things you can write right here in this phase.
Okay.
And then, of course, once the environment is set up, which means that the code has been deployed to testing server, for example, right? And then you can start testing. There is a UI given to you that on a particular URL, this is a testing environment. You can go to that URL. You will have something in front of you, and you can test it.
Okay.
And then since you can test it, now you want to dive into test execution stage. So whatever test cases you wrote in this stage, right? Now you are executing those test cases manually one by one. And then you're verifying the actual product is as expected or not. So you're
Okay.
comparing requirements with the actual product in the test execution stage using the test cases that you had written before. And once of course, once all the test execution has taken place, at the end, we'll have a test cycle closure. And in the test cycle closure, you provide the reports. For example, the testing report, how many defects you found, how many defects were deferred, how many defects were, for example, closed, or how many defects are still open. All those kind of things related to, your findings that you had, during your testing.
Okay. And this is the breakdown of the software development life cycle of the testing stage, right?
This is the software testing lifecycle. Don't confuse with software development
No,
lifecycle.
no, but I'm saying the number four, you see number four test stage in the previous slide, is just a breakdown of
That's
the
right.
number
That's
four.
right. So test stage again, in terms of the development, right? Like
Yeah.
as a developer, I'll be looking at this as a test stage. As
Yeah.
a tester, right? As a tester, my testing life cycle starts right here. Like for example, this one was the requirement gathering,
Yeah.
right? Right? As soon as the
Yeah.
requirements are gathered, I'm analyzing those requirements as a tester so that
Okay.
I can write the test plan, right? So that I can write the test cases. And then if there is something, you know, developed, right, and
Hmm.
deployed, then I can definitely, the environment is set up,
Okay.
environment is done, then I can
Yeah.
execute this.
So this is just a further breakdown of the number four of the software
You
development
can
life
think of
cycle.
that, yes. You can think of that way. But again, as soon as you know the testers, sorry, the developers, they analyze the requirements that what they want to make, right?
Yeah.
What they need to make, for example, not want to, but what they need to make.
Hmm.
At the same point, the same requirements come to the testers, and they analyze
Oh,
what they analyze what to. test and how to test what needs to be tested, what
Yeah.
really needs to be tested. What are the critical parts, what are not so critical parts. So our parts start right there, right next to these guys,
Hmm.
right?
Yeah.
But again, the execution of the testing happens here. Similarly,
Oh, okay.
here, once your environment is set up, only then you can execute.
Okay, okay.
And so
That
there's
makes
these are
sense.
again two different life cycles going on. There's two different job roles, and as soon as the requirements are there, the life cycle starts. Okay.
Okay, so these both of them work simultaneously with each other, both life cycles.
Yes, nowadays they do. Back in the days, it used to be waterfall, as I talked about earlier, that
Yeah.
you wait for all of this to happen. I mean,
Okay.
what they used to do, they would create the whole application in one shot, and then they
Okay.
would test. That used to be the waterfall, which was again not a very smart approach if you think about it, right?
Hmm.
Because what if something you found out like, after spending 6 months that, whatever you were doing was wrong, you know,
Yeah. Yeah.
because testing shows you that whatever you're doing is right or wrong, right? Nothing else shows you that.
Yeah. Makes
Okay.
sense.
So again, do not worry about. So I want you to go over all these slides, and that if you look at it at the end of every phase, for example, these are the phases, right? Requirement
Hmm.
analysis phase, and then you went into a testing phase, then you went into test case development phase, right? So all
Yeah.
these are all different phases. At the end of every phase, there is something being delivered. Okay,
Okay.
worry about the names of the right now RTM. It's a requirement traceability metrics. We'll talk about this, what it is really. We'll see all of
Hmm.
that. Automation feasibility report, as the name suggests, there is a report that tells you that if automation is possible or not on this, right?
Yeah.
Uh, these are the kind of things that gets delivered at the end of every phase. Um,
Okay.
and this is expected of you as a tester. So again, go
Hmm.
over them. And again, there's a lot of things. For example, test script. We haven't looked at test script right now. So don't worry about the things that doesn't make
Yeah.
sense now. But go over them, read them, all these phases one by one, see what is happening and what is being delivered at the end of this phase, right?
Hmm.
If you have any question, write it down and ask me in the next class.
Okay.
Now, one last thing that we should look at is the acceptance criteria, or in other words, entry criteria and exit criteria. Uh, the entry criteria gives a prerequisite items that must be completed before testing can begin, right? So,
Hmm.
for example, the environment should be set up, right? For example, the database should have, or that we should have the data to be tested, before we can start testing. We should have our test data ready, right? So there is
Yeah.
a lot of entry criterias like that, right? You can also think of entry criterias as prerequisites, simple prerequisites, right?
Hmm.
And
Yeah.
similarly, there is exit criteria or acceptance criteria. Now, the exit criteria, if we go back a second, these are the different phases. In order to enter into one stage, right? For example, requirement analysis stage, if I need to enter into this, the entry criteria would be that I should have the requirements to analyze,
Yeah.
right? Similarly, the exit criteria of this would be if I want to exit out of this, that I have analyzed all the requirements. That should be
Okay.
exit criteria of that. Whereas similarly, acceptance criteria is also something that is given to us in the requirements as well, that in order for me to accept your application, these are the criteria that should be met. As a client, I can only accept when you meet these criteria.
Okay.
Okay, so similarly, we have exit criteria and acceptance criteria in order to exit out of the phase. Also, there is another, again, acceptance criteria is the same term that could be
Yeah.
used within the requirements itself that say that, I would not accept the application, like in other words, I would not accept the application if the acceptance criteria is not met.
Okay. That
Okay.
makes sense. Yeah.
So that's pretty much it in terms of the software, the fundamentals, the introduction and the fundamentals.
Yeah,
Again, really quickly, that this is you know the nature of the development is that it needs to be tested, because if you think about it, like you're writing programs in a programming language. Sometimes what happens that in a natural language, let's say in English, people don't understand it, right?
yeah,
What if, what about the code, which is not even a natural language? So the chances are that there's going to be mistakes, which is why, this job exists, testing job exists. Okay, so it's an extremely important job. We have seen it has cost companies millions, not just in terms of money, but in terms of satisfaction, customer in front of instead of, sorry, also in terms of the reputation, right? So all those things. Um, Now there's two main types, main categories. One is the functional, the other one is the non-functional. Functional talks about the functionality of the application, whereas non-functional talks about the look and feel of the application. The hierarchy, unit, integration, system, and then at the end is the acceptance. It's the same acceptance criteria. If you think
yeah,
about it, all those
mhm,
acceptance criteria have to be met for me to even start the acceptance testing.
yeah.
Um, and then there is 7 principles of testing. Again, nobody's going to ask you this in any interview. This is for you, to keep it in mind, because you'll be a tester and you will see situations and you can relate to these principles.
Yeah. Okay.
Software development lifecycle, there's 6 phases, and each phase has its own deliverable. Each phase, work on one particular thing at a time. Similarly, software testing lifecycle, every phase there is entry criteria, there is exit criteria, and then at the end, acceptance criteria, which is that this should be met for me to accept your application. So,
Okay.
okay. Any,
Yeah.
any question before we can conclude?
No, I believe I've asked all the questions during the process itself. What I wanted to ask is stuff like this, which is more theory based. I'm gonna go ahead and take more detailed notes after the PowerPoint is completed on my own time. And while I'm doing that, I may have more questions on the next session.
Yeah, yeah. Anytime. Again, like, we're not limited to at the end of the class or anything like that. Um, we can start with the questions, the class, we can have the questions in the middle. Again, the whole point is that any question that, is there, we'll
Mhm.
answer that. And one more thing, your question is not stupid. My answer could be stupid. Okay, so anything that is in your head, throw it at my way, and
Yeah.
I try to answer that.
Yeah, with these types of situations, when it's more theory based, I feel like the best thing to do is write everything down so you can actually understand it better as well. So that's what I'm going to be doing. I'm going to be writing down a lot of the content which I saw in your PowerPoints. I think they're very helpful, and the way you explained it made a lot of sense.
Thank
So
you.
for it to stick in my brain, I'm going to be writing these down so I can basically remember and kind of come back to these things later on when we do more hands-on work. What do you
Yeah.
think?
That's right. That's the approach that I want you to take. Again, if you're comfortable with everything here, then you'll be comfortable with the next class, right? So, uh, do your own way, prepare, read it, whatever information that is in here, it's for you to read. Now, again, there's a lot of things, you see RTM over and over. We haven't
Yeah.
even talked about RTM. Don't worry. We're gonna look into all of those things. That doesn't make sense. But again, if there is still something that you think it's worth asking, go right ahead. Ask me in the next class before we actually jump in.
Okay, no problem.
Awesome. So I think let's call it a night, call it a day now, and
Yeah.
we'll connect again day after tomorrow.
Okay, thank you so much.
All right. Thank you so much, Wade. Talk to you
Take
later.
care, Braz.
Bye
Bye.
bye.